Hello, we're going to look at discrete maths, MATH1081, Chapter 1, Question 13. Now this question gives us two sets A and B. We take the union of those and take the power set, and then we take the union of the power sets of each of those sets. And the question asked us to find, is there any relationship, any containment relationship between these two sets? The question doesn't actually tell us what we're trying to prove. It's asking us firstly to discover what the relationship might be, if there is any, and then we have to give a proof of that. In this case, with power sets, it's very difficult to draw any kind of meaningful Venn diagram for these to actually see what's happening. So what I like to do with these, to get a feel for the problem and to work out what exactly might be true, I begin by doing a nice simple example. And because power sets get big very quickly, you keep the example fairly simple. So I'll take A to be the set containing 0 and 1. I don't want this to be too big, but I don't want it to be too small either. And I'll take B to be the set, I want something in common, so I'll put a 0 there, and I want something different. So I'm trying to make these two sets have some overlap and some non-overlap, so that whatever happens to these two sets when I look at this, ought to give us some idea what's happening generally. So if I look then at A union B, that will give me 0, 1 and 2, and I can work out the power set of those. You should be already thinking, well, there should be 8 elements here. I've got 3 elements in here, so 2 cubed is 8. There should be 8 elements in the power set. So I have the empty set, set containing 1, set containing 2. Then I've got all the pairs, 0, 1, 0, 2, 1, 2, and the whole set itself, 1, 2 there. And again, I'll just double check that's correct. I should have 1, 2, 3, 4, 5, 6, 7, 8 elements in the power set. Okay, so that's what that set looks like in this particular example. And if I look at the union now of these two, well, in the power set of A or B, there'll be the empty set, so that's still there. Power set of A, I'll have set containing 0, set containing 1. Power set of B, I'll have a 0 that's already there. I'll have a set containing 2. So thus far it's looking very similar. Then I'm going to have the whole of the set A and the whole of the set B, but that's going to be it. There'll be nothing else in there. And so comparing these two, I can see, for example, that this element and this element appear in this set, but not in this one. So I guess from this, from looking at this example, we guess, well, educated guess, that the power set of A union the power set of B is contained in the power set of A union B. So that's going to be my guess. That's what I think is true after doing this particular example. Now if this question was, say, out of 4 marks, that really only gets me 1 mark so far, because I've got the result, but I haven't got a proof of it. So now I have to give a proof of this result. Now remember that these objects are sets. These are unions of power sets. So if you look at the example, each one of the objects in here is actually a set. So I normally use capitals for sets. So I'm going to use the usual method of setting out. Suppose X belongs to power set of A union power set of B. Immediately write down what that means. That means it's in the power set of A, or it's in the power set of B. Now I'm going to unpack this notation a little bit. If X is in the power set, that means that X must be a subset of A. And if X is in the power set of B, that means X must be a subset of B. That's what the power set means. Again, keep your eye on the goalpost. I'm trying to get to the power set of A union B. So at this stage I say, well, if X is a subset of A, that means all the elements of X are in A, or all the elements are in B, or possibly both. Then that means all the elements of X are in A or B, so I can write X as in A union B. And if X is a subset of that, that means it belongs to the power set of A union B. and that means I'm finished. So that tells me that the power set of A union the power set of B is a subset, and also the example that I did shows the inclusion is proper. Well, at least in general. Because in the example, we saw these sets were not equal to each other. And that finishes the proof.